execution, we assume that the application is deployed, the data population is done, the test injector is also deployed on the requisite set of hardware boxes. Most of the times the test injector would reside on a simple set of laptops or personal computers that would suffice to even handle several thousands of users, because the footprint per user is relatively quite small. It's generally in the range of about a megabyte or so. So each virtual user can run as a thread in a desktop. But you need something to control all these virtual users, be it spawning them or be it terminating them or passing them certain values. So that's called a controller, to control the behavior of the users. So what are the features of controllers that load testing tools give you? Well, you can specify a think time per user action, for example, data entry or idle time. You can have inter-iteration time too. That's the time between two iterations of a business transaction. Now, think time and inter-iteration time can be provided as recorded when the actual user went through the actions. You can in turn also specify them as fixed deterministic values, for example, a think time of 5 seconds. Or you can provide a distribution where the think time would be randomly distributed. For example, a uniform distribution where values range from 5 seconds to 10 seconds. So that you have enough of variety in the way users are going to behave. Then with the controller, you can have various recorded scripts and scenarios, and you can specify a mix of them, that I want 10% to come from this scenario, 20% from this scenario, or you can give a user mix that I want 30% finance users, 40% HR users. And you can also decide how many users are going to come per desktop as far as the deployment is concerned. You can specify the overall run duration either as a time value, say for example the script should run for 30 minutes, or you can give a number of iterations that totally I want the scripts to run 1000 times. You can also specify the ramp up of users. So for example, if I want 5000 users, it's going to be pretty impossible that to really spawn off all 5000 users in 0 time. So you may want to say that I want to ramp up users, let's say 100 users every 10 seconds. Or you may want to specify more in case you're going to have a very sharp amount of logins in your system. And likewise, you can also specify a ramp down phase of users, that once your test is over, you may want to see what's the impact of decreasing load on the system. And that's called a ramp down. Once you're looking at the execution, say you've got the scripting, you've got the scripts executed, the test has run for a certain duration. Now it's time to analyze. So what happens in analysis is that the tests are run and the tools that are there would give you a rich set of reports, graphical reports and text reports to let you do response time analysis, throughput analysis. You can look at number of virtual users as a function of time. If you have monitors inbuilt during the execution, you can have server utilization. You can also look at network traffic, because many tools will have built-in monitors. You could also supplement them with third-party monitors. Now just having the analysis is not enough, because the tool will give you the reports. You need to be able to cross-check the reports. You need to be able to correlate them and do your own analysis around the reports. For example, when response time goes high, you need to correlate. Is it because utilization has shot up, or because network traffic has gone up, or number of users has shot up? And this way you can be able to correlate the effect with the cause, because response time and throughput are outputs and the cause is the inputs, which could deal with virtual users, think times, or the system state. Now, having said that, we need to make sure that we are following a proper performance testing process, because it's not just one round of scripting, execution and analysis. To start off, you need a performance testing plan which is signed off by a customer. We'll not get into the details in this course. You need to execute your project, performance testing project, as per the plan. You need to make sure that you have a system under test that's ready. You need to have your scripts created and modified with parameterization and correlation. Then you execute your test and monitor it. You analyze the test. After analysis, you check, are the performance targets met or not? If the performance targets are met, then you would say yes, the performance test is complete, and you need to prepare a report, and you need to be very specific in the way in which you prepare reports. If the performance targets are not met, then you would go about doing platform and application tuning. Now this is not necessarily to be done by the tester. You would typically have a team, which we will talk about in a couple of slides. With performance platform and application tuning, it may require scripts to be modified because the application might have undergone change. If there's no modification in scripts, you go back to execution. If there's modification scripts, then go about modifying them, and then again go through the cycle of scripting, execution, and analysis and tuning until you reach a level of performance targets being met, or maybe you have simply timed out and the business takes a call, well, we've had enough of optimizations done, let's hope for the best when you move to production. Ideally, if you started early enough, you will be able to have a good handle on performance, and you can budget a good amount of time when you're doing performance tests. So never plan on it in a hurry. Do budget your time for it. Some of the best practices in performance testing are that you need to always validate your output. At the end of the day, when you do functional testing, you have an output which you know, and you can cross-check your test output against the desired output. In performance testing, you don't know what's going to be the output to start with. So you need to make sure that your run is completed successfully. You need to make sure that if there are n virtual users, does the response time for manual user match with that of the tool? You need to deal with, we've dealt with very fundamentals of Little's law, so you need to ensure that with Little's law, you've got number of users, throughput, response time, and think time. Do these four quantities match in your report or not? And you need to have some assertions in place in your scripts which the tools can give you with respect to script response, as the script runs successfully, with respect to the SLAs. You also need to choose a meaningful run duration, because very often people tend to be hasty and choose a small duration, and they'll end up in doing tests in the transient phase where the system is not stabilized. So for example, in the initial phases, your users are ramping up, your system cache is cold, you may not always get the response that would be there in a true system that's been running for a number of hours. So you need to know that when does the system kick into steady state, when the results are stabilizing. This can be viewed graphically. And you also need to know that once you're in steady state, after a certain time you will get diminishing returns. Your response time averages are going to converge. They are not necessarily going to be any better in quality just because you're going to run the test for much longer. So you need to choose the right set run duration, which can come out of a few pilot tests that you do initially during PT, and decide, well, should my run duration be 5 minutes or 20 minutes or half an hour? It can be viewed graphically once you see the response times or the utilization stabilizing. It's very important in performance testing to have single user or light load tests, because a lot of performance bottlenecks can be found initially even when there is just a few set of users. People are usually optimistic and they would say, okay, I have to load test with 10,000 users, so let me assume that things will work fine, and if I hit a wall, then I will tune it. Well, it's very difficult, and your system can have all types of bottlenecks with a large number of users. But a lot of basic application performance can be figured out once you do a single user test, because you can run single user tests very fast even without having a tool scripting done. And once you get these bottlenecks, the first 2-3 iterations can be very significant in getting rid of application bottlenecks. You also need to note that your performance test environment is not as good as your production environment. Excuse me. So you need to make sure that what are the gaps between test and production. Quite often the gaps have to deal with database volumes. So how do you deal with database volume generation? Can you take a copy of production? Can you create synthetic data? Can you mask data and replicate it? How do you bridge gaps between the local area network that you use during performance testing and the wide area network that will be there in production? Well, you can use WAN emulators such as Shunra or WANM or some of the others that I mentioned here. How do you take your performance output and how do you extrapolate your analysis? So that if you, let's say, tested for 5,000 users and in production you will have 7,500 users, you need to make a call that how are the results going to extrapolate. If you have a number of interfaces in production which you could not replicate in test, then you need to make sure that at least for the critical interfaces you provide some stubs so that they can simulate the behavior of external applications. Last but not the least, you also need to choose meaningful think times. Quite often people tend to choose very hard-coded values which have nothing to do with the business. The think time has to come from a business user. So it may make sense to have small think time values initially when you want to accelerate the load and get done with a lot of iterations fast. But once you're coming close to the last rounds of load testing, you need to have realistic think times. Now, if in case you're not aware and you cannot have access to a real business user, you can use Little's law as mentioned above, where n is equal to x times r plus z. So you know the number of users n, you know what your throughput you're targeting x, you know the response time target, and based on that you derived what's the average value of think time. Now coming to the PT team composition, the team composition is not necessarily only testers. You would have a PT lead for testing, planning, coordination, and you would have team members for scripting, execution, analysis. But along with these key members, you also need during the test to have infrastructure administrators who would set up the environment for you, who would do the performance monitoring, analysis and tuning of the hardware, operating system, network and platforms. And you also need application developers to be in the team part-time, because they are the ones who will find out bottlenecks in the application and tune the application based on the analysis that you provide to them. So you have to make sure that performance testing is a coordinated effort across a number of stakeholders. It's not just a bunch of testers who are going to be critical to the success of performance testing. And as I mentioned earlier, apart from load testing tools, you need a lot of system and platform monitoring tools and application profilers, which we've talked about some of these in the code optimization section. Now, apart from load testing that we spoke about, some of the common types of performance testing are scalability testing, wherein once you're done with load test, you want to see is whether the performance scales with infrastructure. What happens if I go from one server to two servers? Do I get horizontal scalability? You may want to do spike testing or resilience testing, that what if there's a sudden spike in workload that lasts for 2 minutes? Can your system handle the spike? How long does it take for your system to absorb the spike and function normally? You may want to do stress testing to figure out what are your breakpoints in the application. So today you may have 5,000 users, but what would happen 1 year down the road when you have 10,000 users? Is your system going to wobble? Is it just performance that will matter, or it will become completely unavailable? So you need to look at the breakpoint of the system. Related to that is what we call soak testing or endurance testing, availability testing, especially with 24/7 systems. You want to know how long can load be sustained before the system crashes, either because of a memory leak or because of some other system state where resources keep leaking out. And lastly, you may also want to do volume testing, wherein you want to look at what's the impact of increasing database volumes to your overall performance. Now the last slide in the section is just to highlight to you that you may feel that if I do a lot of performance tests, why can't I build my own scripts? Well, given that load testing tools are there in the market, they provide a lot of other features that we've not really touched upon in this presentation. So for example, we spoke about HTTP requests being recorded. Many tools will give you multi-protocol support where they can record JDBC calls, TCP/IP calls, Flex calls, Oracle NCA calls. If you have a proxy in the environment, your tool will give you support to be able to handle the proxy during replay. If you're load testing within your LAN environment across one or two desktops, the IP addresses are the same. But what if you want to be able to load test with a load balancer that would do the balancing based on IP address? Well, you have tools that give you IP spoofing so that they assign different IP addresses to different virtual users. and this way the load balancer will think as if it's a real user coming into the system. Many tools also provide you with integrated WAN bandwidth and latency settings. Many tools do not give that setting as well, and many tools will give you integrated performance monitoring tools, including tools for real-time monitoring. So that concludes our session on performance testing. The session was to introduce you to the basic concepts in performance testing. It is not meant to give you a tutorial on the various tools that exist, but having gone through the session, it should be quite easy for you to pick up around the commercial tools in the market and be able to create your own processes when it comes to do performance testing.